Okay, this is going to be our third example here, and this one's going to be a little bit different than the first two we had because this is actually a real world example where I was watching a video by a kind of famous engine builder by the name of Steve Morris, and he was talking about as part of a larger conversation. But the first part that you had to figure out the rest of what they were talking about was essentially at 7,000 RPM. How long is the intake valve open for? And they meant just for one cycle, like from one time that it opens and closes, how long is that amount of time? And I think in the video he said he thought it was just top of his head. He was thinking maybe like hundredths of a second. So I went ahead and calculated it using unit conversion and came up with an answer. And I was watching another engine builders. He's really more of a head porter, but also does some engine building video. And he attempted to calculate it and came up with an answer different than me. And I watched a different engine builder try and do the same calculation, and he came up with a different answer as well. Not their two answers weren't the same, but all three different answers essentially. And I even plugged it into ChatGPT just out of curiosity to see what ChatGPT would spit out as the answer for it. And I think ChatGPT came up with the same answer as the first engine builders video, the head porter, but they were wrong. Both engine builders and ChatGPT were actually all wrong in this case, and both the engine builders I think have gone back now and corrected themselves and come up with the correct answer. But I want to go over how to solve this problem, and then go over where they were making mistakes so that you can avoid doing the same thing, and even show you where ChatGPT made a mistake. So again, you can avoid making those same mistakes in your own calculations. So the other piece of information we need one more piece of information actually to be able to calculate how long it's open for, because in addition to the RPM, that makes a difference, but also the camshaft makes a difference in terms of how long is the intake duration of a camshaft. And if you don't know what that is, that's okay, I'll cover that briefly. But in this case, what the given was in order that we were using for the calculation was 300 degrees. It's the intake duration. And it's important to note that in this case, that 300 degrees is what's called advertised duration, or essentially seat to seat. That's basically from the time that it opens to the time that it closes. And whenever intake duration or exhaust duration of a camshaft are given, that 300 degrees is always in it. I'm going to point out this more than once in this video because, again, it comes up where people made errors, is that it's important to know 300 degrees of what. And in this case, those 300 degrees are of crankshaft. Whenever we give intake durations or exhaust durations of camshaft, it's always in terms of degrees of crankshaft rotation. In fact, I'll put rotation there just for clarity. So with these two pieces of information, that's all we need actually to be able to calculate this. So first thing to discuss is actually what RPM means. And the RPM is revolutions per minute. And again, I'm going to point out, even though I just said I would, I'm going to point it out again immediately, that 7,000 RPM is 7,000 rotations of the crankshaft. So I just want to point out that both of these are in terms of crankshaft rotation. The intake duration is in degrees of crankshaft rotation, and RPM, whenever we talk about RPM of an engine, we're always talking in terms of revolutions of the crankshaft. There will be some problems coming up where it will be really important to distinguish between, because not everything in an engine and in the drivetrain is spinning at the same speed. The camshaft is spinning at a different speed than the crankshaft. Very often you might have like a balance shaft in the engine that is spinning at a certain speed. You can have in the transmission, for sure, that's sort of what we do in a transmission. is convert from the input shaft speed to the output shaft speed. So it's important to note when you're doing these calculations, try and be specific about what you're referring to, because otherwise it's really easy to get yourself confused and lost about what you're talking about. And you'll see that as I work through this. So I'm going to start with this 7,000 RPM. And as we talked about, you can either write it is 7,000 revolutions, and I'm going to actually, again, right here, of the crank, just for clarity, 7,000 revolutions per 1 minute. Or, as I said before, you could write it as 1 minute per 7,000 revolutions. Either of those are perfectly acceptable. That's two different ways of saying the same thing. And in this case, I'm actually going to use this one, and I'll, again, talk more about why as I get towards the end. It'll become clear as to why I chose this, to write it this way. So you start off with 1 minute per 7,000 revolutions. And so I'm going to go ahead and convert this minutes to seconds, because I could leave it in terms of minutes, but we know that this is a very short period of time, right? Like how long that intake valve is open, it's opening and closing pretty fast, especially at 7,000 RPM. So, you know, if I get like 0.00083 minutes, like what does that mean? It doesn't mean a whole lot. It's hard to figure out how fast we're talking. So it makes sense to go ahead and convert that to seconds. So I'm gonna go ahead and do that. And so I'll put my minute on the bottom, and I put my 60 seconds on the top, and it's crossed out. So now I'm in terms of seconds, which is where I want to be. Now I need to get rid of these revolutions, right? Because my final answer really needs to be just in terms of time, in terms of seconds, but I'm in seconds per revolution. So I need to find a way to get rid of these revolutions. Well, I can't get rid of them yet because my other piece of information that I have is this 300 degrees. And why this is different than the first two we've covered is because this is where you have two separate pieces of information that need to be accounted for when you're doing your conversion. And as I talked about in those first two videos, you really want to try and bookend your unit conversion as you're going through, so that you start with one piece of information on this side, and then your last thing at the end is the other piece of information that is specific to your problem. Because again, the 7,000 RPM and the 300 degrees of intake duration, those are specific to our problem. Those are not universals. However, everything in between is a universal, and we need to only really be using these universal conversions. Like 1 minute is always 60 seconds in between. So I need to get rid of these revolutions. So the way I'm going to do that is I know that 1 revolution is 360 degrees. And then my revolutions talk out. And that is a universal constant. 1 revolution of anything that spins in a circle is always 360 degrees. You can use that anywhere you're converting revolutions to degrees. And now if I stop right now, I would be in terms of seconds per degree, but I don't want that. I want to just know, I just want a time, so I just want seconds. So this is where I end up with my last piece of information, because now I've got this in terms of degrees. My last piece of information that I need to account for is in degrees. And again, this is okay because this is revolutions of the crankshaft. This is 360 degrees of crankshaft rotation. So I can use these and cancel each other out. So I write my 300 degrees here. My degrees cancel out, and I check and see what am I left with? Just seconds. So my answer is going to be in seconds. And that's it. That is the sum total of what you have to do. You have the two pieces of information that were specific to your problem that are bookending it, and in between you have these universal constants that are always true everywhere, and that's all you have to do to convert it. So if I do this, I'm gonna go ahead and plug it into the calculator, and I'll show doing that here. And as we've talked about, you always first thing you do is open up your parentheses, and then I'm gonna skip the ones like I've talked about, but I have 60 and 300 on the top. So I have 60 times 300, close parentheses, divided by open parentheses. And then on the bottom I have 7,000 and 360, because the only other thing is just a 1, so I don't have to enter that. So 7,000 times 360, close parentheses, equals, I always have a hard time holding this and writing at the same time, so you're just gonna have to bear with me, 0.00714. And it's important to write, do not stop right here and be like, that's my answer. No, units. You need to put your units on your answer as well. So seconds. So 0.007 seconds, which is also the same as, and I'm gonna round it off. That's the same as 7 milliseconds. So that's how long it takes at 7,000 RPM for the intake valve to open and close when you've got a camshaft that has 300 degrees of intake duration. So pretty fast. So you said the guy in the original video was thinking hundredths of a second, and it's like, really, no, it's thousandths of a second. It's less than 1/100th of a second. It's 7,000ths of a second. So let me talk a little bit here. I'm gonna set this back up, try to here, so that you can see what I'm doing. Let me talk a little bit about the errors that I've seen people making, including the other engine builders that were trying to solve this problem. I would say the number one error that I saw was they weren't writing down their units. They were doing conversions similar to this, but they didn't write them out like this. It wasn't very clear. Their papers were, if I showed you them or when they were writing it out, it was a mess. It was it was a mess to them too. I could tell when they got to a certain point, they were getting confused about like, they would do something like divided by 60, didn't write down their units, get down, and then they're like, oh, this is this. And then they would go and try and do something else with it. And I was like, well, you can't convert one to the other like that. Your units wouldn't drop out the way, well, if you're not writing your units, they can't even tell that they're doing something that you can't do, and that the units wouldn't drop out like they want them to. So that's why I stress it's really important to write your units and even be specific about what it is. Somewhere you need to know, like if you've got revolutions, like revolutions of 1. This is in terms of the crankshaft, this is in terms of the crankshaft. This is why I didn't need to do anything else with this. It's really easy to get confused on one like this because you start thinking about, oh, it's a 4-stroke cycle and the camshaft spins at half the speed of the crankshaft and blah, 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 blah. And like, that's what they did. And that's how they confused themselves. And in fact, that's what ChatGPT did. I'll show you that here in just a second. That's how they all got the wrong answer. And I was like, well, you didn't even need to do that, right? Because this is in rotations or revolutions of the crankshaft. This is in degrees of crankshaft rotation. We don't really care about the camshaft. We didn't have to do any conversion in this case to how fast the camshaft is spinning. So that was a case where knowing a little bit too much, made it more difficult for you. So yeah, that's the big thing I would say is write your units down and make sure that they cancel out. And I'm going to show you an example of where they don't cancel out, where people might think they do or aren't realizing that they're making mistakes. So a good example of that is if I say 3 feet times 2 feet equals what? Well, a lot of times people will say it equals 6 foot. That is wrong. It does not. 3 foot times 2 foot is not 6 foot. It's 6 feet squared. Or if you want to say another way, 6 square feet. That is correct. So they're not the same. When you have 3 feet times 2 feet, that does not equal 6 foot. It equals that 6 foot squared or 6 square feet. And the reason I say that is because when you're doing these calculations here and getting things to drop out, like let's say I had done something over here where instead of this, I had ended up with and I had another 60 seconds. Equals 1 minute. And I get to the end and I'm like, oh, like, let's say for somehow I ended up with the, like, that wouldn't happen. You would see you'd have an issue where, like, well, you'd have an extra second in there in terms of a unit and a minute that it cross out, because they only get to cross out once. So you would have already made an error by crossing that minute out. But let's say you did. If you ended up with seconds and seconds, your answer would be in seconds squared, which is not the same. Totally different. If you do that, that is a big warning sign that you've done something wrong. If you go along and you end up with seconds twice, minutes twice, degrees, anything that is not just exactly what you want in terms of a unit one time, that is your sign that something has gone wrong and you need to go back and figure out what it is. Along that same line, what I'll see people do sometimes is, in other videos I've worked out where I got to the edge of something. So like, let's say I had 60 seconds, 1 minute, and I had, something, a bunch of calculations before this and get to this. So I need to carry it down to another line. I've seen people like try and carry this down to here so that they can remember, oh, I need to, if they want to like cancel out minutes, like they're like, oh, I need to put that like 60 minutes, 1 hour, and they put it like that. The problem is don't rewrite this on the next line here, because now you've got it twice. And as we just talked about, it's not the same in terms of like your number will be wrong because you're going to have an extra 60 multiplied in there that shouldn't be there. And your units are going to be wrong because you're going to have seconds and seconds and stuff. So it's not the same, and it will mess you up. It'll throw you off. So if you need to go down and start a new line, it's just like writing a sentence. Like, you don't have to rewrite the last word of each sentence at the end of a edge of paper when you go down to the next line. Like, no, you can tell that, oh, that's where I ended and this is where I start. Do the same thing here. You would do it like this. And now my minutes would cross out top and bottom here, and then I'm sure my hours and seconds, like one of these would have crossed out somewhere else before. And so that will keep you from messing yourself up. So don't make the mistake of rewriting what you wrote here down here when you go down to the next line. Just like, no, it's one continuous line, and wherever it stops here, just start new here, whatever your next thing is. Let me look at some more of the issues that I see people make. Another one that I have seen is people will try and go from one unit to another unit and not know exactly how to do it. And so they'll try and like look it up or try and do it in their head and stuff. So a good example is like centimeters to millimeters. Can you do that in your head? Maybe. Like some people certainly can. They can tell you exactly. If I say if it's 137 millimeters, they can pretty quick do millimeters to centimeters in their head. What I would encourage you to do is make it easy on yourself, because you're likely to make a mistake about like, wait, which way do I move the decimal place on something like that. If you want to do centimeters to millimeters or anything that's of that same sort of idea, let's say I have 72 centimeters and I want my answer in millimeters. Convert to meters from there, because I know that there's 100 centimeters in 1 meter. And I know that there is in 1 meter, 1,000 millimeters. And then my centimeters cross out, my meters cross out. I'm left in terms of millimeters. And just plug it into your calculator. Like, let your calculator do the hard work for you instead of in your head, again, trying to do these sorts of things. That will make it easier for you. So I think anytime you're doing a distance, I gave you that the 1 inch equals 25.4 millimeters. I would always use that. For one, that's pretty precise. That's pretty accurate. If you this is where I would use as that bridge to cross over between like standard or imperial to, which is, you know, inches, feet, whatever, to metric, millimeters, meters, kilometers, whatever it is. This is what I would always use. Like, I would want to see this in your calculations when you're doing that crossover, because then I know that it's accurate. I know that you haven't had to round anything more than you needed to. And I also know that you haven't made a mistake in going from like centimeters to millimeters or anything like that. Like, to use this as your crossover and do like this to convert instead of trying to go directly to it. It's people try and save themselves time and end up getting the wrong answer because of it. The other thing is, when you book in, let me show you why I started with the, so why did I start with this? Well, because if I did it the other way, so I don't know if you can maybe just barely see that at the top. Instead of, let me get a fresh piece of paper. Instead of doing the 1 minute per 7,000 revolutions, if I do it this way, I can do almost all the same way as I did, just flipped. So minutes would cross, and then I can do 1 revolution. It's 360 degrees. Revolutions cross out. My problem here is, so now I'm in degrees per second, whereas before, you know, if I stopped right here, well, I don't want to confuse you because I crossed some of that out. Let me just keep going with this here. I end up with degrees per second, and I want to get rid of this 300 degrees of intake duration. That's my last piece of information I need to take into account. Well, the problem is my degrees is on the top now. So really the only way I could do that is by putting it on the bottom and having them cross out. I would encourage you not to do this. Like, this will mess you up with it essentially upside down at this point. When you get to, especially a short one like this, just be like, oh, nope, I need to flip it because I need to be able to end up with seconds on top, not on the bottom. And I would highly encourage you not to, your non-universal thing, the thing that is like given in the problem, whether it's the 7,000 or the 300, but in this case, particularly the 300, because it doesn't have it's not 300 degrees per anything, it's just 300 degrees. You don't want it on the bottom. It needs to be on the top. So your options are, you can rewrite it, which is, you know, what I did. And in fact, when I originally did the problem just on the back of a thing, because as I've told you, a lot of times you don't always know in your head, like exactly where you're going to, and that's fine. But when you start to see, oh, I figure out where I'm going now and I'm upside down for where I want to be, you need to find a way to flip it. And so I would say, for sure, don't do that. Don't put the 300 degrees on the bottom or whatever the extra piece of information is. You can rewrite it, you know, so there's basically like, oh, I need to flip this thing. If you wanted to, you could put some arrows here. If you wanted to leave that 300 degree like that, you could put the arrows in there to let you know when you plug it into your calculator to flip it. So you would basically put everything on the bottom in parentheses first in your calculator, and then divided by everything on the top in parentheses, and just know that your units also flip. So instead of seconds on the bottom here, with seconds being the only thing left, you would end up with seconds on the top. But starting out, I would just rewrite it. It's going to be easier and not confuse yourself as much. When you're ready to start doing this, where you're like, oh, I can do that, and it doesn't, I'm not worried about it messing me up, then, you know, knock yourself out. But if you are not 100% confident about what you're doing yet, just rewrite it this way and make it easy on yourself so that you can be like, okay, I feel this is gonna give me the format that I want and the right answer that I want. The other alternative would be, I'm going to show you, and actually the calculator on this, that you just, like, if you search calculator on Google, the calculator it gives you is actually really bad about this. It's not very good for doing reciprocals. So when I say reciprocals, what I mean is, like, let's say you do, and it's pretty, like, let's say you do a longer one, you're like, oh, I do not want to have to rewrite all that out again. And I wanted my answer to be in seconds per meter, but I ended up with it in meters per second, like it's upside down. Like I said, this is when you get to the end and you're like, oh, it's in meters per second, but what I want is seconds per meter. So let's say you end up with 37 meters per second. So what is that in terms of seconds per meter? The way you would do that is, and again, it depends on how your calculator is. I wish I could show you the one on my phone, but I can't because I'm recording with my phone. There's a button that, so like, let's say you plug everything in and you're up with 37 and your units is meters per second, but you want it in seconds per meter, you need it flipped. There's a button on some of your calculators that's gonna be a 1/x. That is your inverse button. So what you would do is you get your answer, you type everything in, you'd have 37 on your calculator, you would hit 1/x equals, like as the two buttons you would press, you'd have to press 1/x and then equals, and it should give you the inverse of this. The other thing you can do is you can take, and what this button is essentially doing is to get from here to seconds per meter, you would do 1 divided by 37, and that will give you your answer. So if I do it, I'm doing it on the calculator here, but just I'm typing in 1 divided by 37 on here, it's 0.027, and that's rounded seconds per meter. That's how you do the inverse if you need to flip it. Like I said, but in a situation like this, I wouldn't do that either. I would only do that if I have something like where it has a top and a bottom, where it's like meters per second or seconds per meter or miles per hour, and I want to know hours per mile. I would do it like this. When you have something like this, don't do that. It is important to point out that it is totally okay for your beginning piece of information and your ending piece of information, the bookends, the things that are specific to your case, for one or both of them not to have something on the top or the bottom, if it is something where you need to account for two pieces of information. So let me write one out. So the first one we start out with, and like example number 1, we try to convert feet to meters. You know, we were 6 feet equals how many meters. And so I just started out with 6 feet, and then from feet, I went from, 1 foot, 12 inches, feet cross out, dot, 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 dot. That's totally okay for that not to have anything below it. In the same way on this problem here, when I got to the end, when I wrote it out here, and I kind of messed it up on this paper, so hopefully it's not going to get too confusing because I crossed it out to try and do that other example before. But it is okay at the end of something to have like top and bottom, and then I needed to just have 300 degrees just on the top. That's totally fine, as long as it is your beginning piece of information or your ending piece of information when you need to have two things that need to be taken into account to get the right answer. Do not ever, and I shouldn't say ever, but at this point, don't use something like this inside the middle of the problem, because that's not a universal thing. I have seen people, and I understand why they did it, but it ultimately kind of led them to getting the wrong answer. So somebody converted that piece of information, that 300 degrees of intake duration, they went ahead and converted 300 degrees as a proportion of 360 degrees, so which comes out to like 0.83, and it's actually 0.83 repeating revolutions. And don't do that, because now this is essentially like a universal at this point, because 300 degrees is always 0.83, and it's actually 83 repeating revolutions. That would be something that would go in the middle of your problem. If anything that is a universal goes in the middle, not at your either end. And you shouldn't be doing that with a piece of information that is specific to your problem. The pieces of information that are specific to your problem do not require you to try and turn them into a universal. And in turning them into a universal, it's going to take you down the wrong path and give you the wrong answer because of that. And as you saw, when I worked the problem out, I didn't have to ever do that. So if you find yourself doing that, stop. You're doing something wrong. Everything in the middle should be just always a universal, and everything on the ends, at least on the beginning end for sure, the beginning end should always be something specific to your case. And then if you have a second piece of information that needs to be taken into account, that needs to go at the end, and everything in between is those universal conversion factors. Hopefully that makes sense. And I think that those are really the biggest issues that I've seen. And like I said, I've tried to give you some things that you can do if you end up with it flipped from where you want to be. Like I said, you end up with meters per second and you want seconds per meter, something, anything along those lines. Those are the solutions to that. So I'll stop here. The next problem is probably gonna be a pretty long one because again, we'll be working our way through a drivetrain where you have the engine spinning at a certain speed, the transmission parts, different parts are spinning at a certain speed, drive shafts at a certain speed, the wheels are at a certain speed, and then how does that translate into how fast the vehicle's going, etc. So hopefully that answers questions you had about like, can I do this? What happens if I get into a certain situation where I need to fix something? But big thing is, again, write your units down. Your units will kind of guide you to the right answer. And as long as you write your units down, you make sure that they're dropping out appropriately. You don't end up with seconds more than once if you want your answer to just be in seconds, and you leave your non-universal, the things that are specific to your problem, bookending with universal conversions in between. It'll guide you to the right answer. Oh, and I'm inserting this at the end because I realized when I got to the end I forgot to include it. So this is when I typed it into ChatGPT, and I said, how long is an intake valve open at 7,000 RPM with an intake duration of 300 degrees? And so this is what it does, and then I'll go to the second page that has the answer, and you see it comes with 0.00357, so essentially half of what we got, 3.5 milliseconds, and again, that's wrong. And you can see where ChatGPT went wrong. It got itself confused because you have to remember, these are based on what it sees online and what other people are doing. So if people online are struggling with something and coming up with the wrong answer, ChatGPT is going to do that. So it will not save you from being able to do unit conversions on your own. But you can see right here, it starts thinking about the 4-stroke cycle and trying to do it in terms of that. And it says there are 360 full, an engine complete 720 degrees per full cycle. Well, no, it's 4 cycles, 700 degrees, 720 for 4 cycles. And it says 360 for the intake stroke and 360 for the exhaust stroke. That's wrong. We know that it's 180 for the intake stroke, 180 for the compression stroke, 180 for the power stroke, and 180 for the exhaust stroke. So it's gotten itself confused there. But it ends up with this RPM times 720, which is what other people were kind of doing in a way when they were making the mistake. But so it's saying degrees per minute. So degrees is RPM times 720. Well, no, we know that one revolution is not 720. The revolution of the crankshaft is 360 always. And so it, again, got itself confused, kind of overthinking the problem, if you want to say that about AI. And it led itself down the wrong path. So as soon as you were trying to do, one revolution is 720 degrees, you'd be like, wait, no, that's not right. I know one revolution is 360. And so again, if you write your units down and make sure that they're canceling out the way they're supposed to, it'll keep you from making mistakes that, well, essentially ChatGPT made as well. So that's why it came up with the wrong answer, essentially in that situation. So that was that. I wanted to mention that as well.